I am Radhakrishna, mathematics teacher. We are going to continue our topic definite integration, fourth lecture. We have already discussed the properties of all definite integrals, and we solved some problems in the previous class. Now we are going to continue. If integral 0 to pi by 2 sin 2x into sin x dx is equal to k into integral 0 to pi by 4 cos 2x into cos x dx, find k. This is a very important question. Almost a similar question appeared in JEE Advanced recently. First, when the limits are 0 and pi by 2, we have to try the property. Which property? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So, I am taking the LHS. LHS is equal to integral 0 to pi by 2, replacing x by pi by 2 minus x, sin of 2 into pi by 2 minus x is sin of pi minus 2x. It remains as it is. So, it is f of sin 2x into, here sin pi by 2 minus x becomes cos x. Now, if you take this integral as I, this is also I. Usually after applying this property we will add the integrals. So, 2I is equal to integral 0 to pi by 2 f of sin 2x is common, f of sin 2x into sin x plus cos x. Okay. Now, we want to convert this into this form, f of cos 2x into cos x. First, dividing and multiplying by root 2, you will get root 2 here, integral 0 to pi by 2 f of sin 2x. If you divide by root 2, 1 by root 2 sin x plus 1 by root 2 cos x can be written as sin pi by 4 plus x, or before that let us see the limits. We want the limits 0 to pi by 4, no? If you substitute pi by 2 minus x, this function remains same. So, we can apply that property. Which property? Divide the upper limit by 2 and multiply the integral by 2. So, that also I will do simultaneously. We can divide the upper limit by 2, so upper limit becomes pi by 4, so into 2. Now, let us proceed. This 1 by root 2 cos x plus 1 by root 2 sin x plus 1 by root 2 cos x is sin pi by 4 plus x dx. Right. Now, this is 2i, you can cancel 2. Now, limits have changed and function has changed. So, again we can apply the same property which we have applied here. Substituting pi by 4 minus x, replacing x by pi by 4 minus x, integral 0 to pi by 4 f of, what will get here? Sin of 2 into pi by 4 minus x will be sin pi by 2 minus 2x, that will be cos 2x, f of cos 2x into substituting x as pi by 4 minus x, this becomes sin pi by 2 minus x, which is cos x. Now, this is exactly in the form of the RHS. So, comparing this and RHS, what is the value of k? K is root 2. Next question, integral minus 100 to plus 100, minimum of fractional part of x and fractional part of minus x. First, when the limits are in the form of minus a and plus a, we should check the function is even or odd. Replacing x by minus x, the function remains same. Minimum of fractional part of x and fractional part of minus x is same as minimum of fractional part of minus x comma fractional part of x. So since the function is even, we can write this integral as 2 integral 0 to 100 minimum of fractional part of x comma fractional part of minus x. Okay. Now we know that fractional part of x is a periodic function with period 1. Fractional part of minus x is also periodic function with period 1. So since the period is same, period of this whole function is 1. Now we are going to apply the periodic function property. Integral 0 to nt f of x dx is equal to n integral 0 to t f of x dx. This is the property of periodic function in definite integral. So here since the period is 1, write the upper limit as 100 into 1, then this can be written as 2 into 100, 200 into integral 0 to 1 minimum of fractional part of x comma fractional part of minus x. Okay. Now fractional part of minus x can be written as 1 minus fractional part of x. All of you remember this result. So I will write this as 200 integral 0 to 1 minimum of fractional part of x comma fractional part 1 minus fractional part of x. When x lies between 0 and 1, fractional part of x is x only, is it not? So I will write this as x and this as x. It will be 200 into integral 0 to 1 minimum of x comma 1 minus x dx. Now we draw the graphs of y is equal to x and y is equal to 1 minus x and identify which is minimum. Take the coordinate axis like this. The given interval is 0 to 1. In the interval 0 to 1, first draw the graph of y is equal to x. It is a straight line through the origin inclined at 45 degrees with the x axis. What is the graph of y is equal to 1 minus x? It will come like this. What is the intersection point exactly in the middle at 1 by 2? Now you can observe that when x lies between 0 and 1 by 2, what is the smaller one? It is x. From 1 by 2 to 1, 1 minus x is smaller, this is smaller. So the graph of f of x will be integral of graph of f of x will be this black marked straight lines, and now we know that this integral is nothing but area under this graph and x axis. So required integral is this area, except this 200, remaining integral is given by this area. Since it is completely above the x axis, we can say that that integral is equal to area, absolutely. What is this area? This is half and this is also half because this angle is 45 degrees. So area of this triangle is half base into height 1 by 4. So it is 200 into 1 by 4. Answer is 50. The value of the given integral is 50. Next question. integral 0 to pi x sin 2x into sin of pi by 2 cos x. As usual, we substitute x as pi minus x, the property. First, let I be equal to integral 0 to pi x sin 2x into sin of pi by 2 cos x dx by 2x minus pi. Now replace x by pi minus x. Pi minus x into sin 2 of pi minus x will be sin 2 pi minus 2x. What is it? Minus sin 2x. So we will get minus sign here. Here cos of minus x, cos of pi minus x is minus cos x. Is it not? And that minus sign comes out of the sign, then minus, this minus becomes plus. So it will be sin of pi by 2 cos x dx by replacing x by pi minus x, what will get? 2 into pi minus x minus pi, that will be pi minus 2x. Okay. Now after applying this property, what will you do? You will add. Before adding, you change this denominator as 2 pi minus x and this one as x minus pi, so that we can add comfortably. Integral 0 to pi x minus pi into sin 2x into sin of pi by 2 cos x dx upon 2x minus pi. Now adding this and this, 2I is equal to integral 0 to pi, denominator is common, 2x minus pi, and also sin 2x into sin of pi by 2 cos x is also common. So we have to add the remaining terms x and pi, x minus pi. X plus x minus pi will be 2x minus pi into sin 2x into sin of pi by 2 cos x. Okay. Now 2x minus pi cancels. Now write this sin 2x as 2 sin x cos x. 2I is equal to integral 0 to pi 2 sin x cos x into sin of pi by 2 cos x. Dx. Now you can easily guess what I am going to do. Derivative of cos x is minus sin x is here. So I will put either cos x is equal to t or pi by 2 cos x is equal to t, and also you can cancel 2. So put pi by 2 cos x is equal to t. Then differentiating, we get minus pi by 2 sin x dx is equal to dt. So dx is equal to minus 2 dt by, no need to calculate dx because sin x is already there. So I will write directly I is equal to, first sin x dx becomes minus 2 by pi dt, and cos x is what? 2t by pi into sin of t into sin x dx minus 2 dt by pi. Now limits, what are the limits? New limits are, if x is equal to 0, t is pi by 2. If x is equal to pi, cos pi is minus 1, so t will be minus pi by 2. Now we can remove this minus sign and interchange the limits. It becomes minus pi by 2 to pi by 2, 2 by pi into 2 by pi, 4 by pi square. T, another 2 is also there, so 8 by 4 by pi square into t sin t dt. Okay. Now t sin t is even function. Limits are minus pi by 2 and plus pi by 2. So what can you do? Use the property of even function. We can write this as 2 integral. 2 means 4 by pi square into 2 becomes 8 by pi square integral 0 to pi by 2. If the function is even, integral minus a to plus a f of x dx can be written as 2 integral 0 to a f of x dx. So it becomes 8 by pi square integral 0 to pi t sin t dt. Now we have to calculate the integral of t sin t by integrating by parts. I is equal to 8 by pi square integral 0 to pi by 2 t sin t, integrating by parts. First function is sin t, second function is first function is t, second function is sin t according to Eilert rule. So it becomes t into derivative integral of first function into integral of the second minus cos t minus integral derivative of the first integral derivative of the first function 1 into integral of the second function minus cos t dt. Okay. Here we have to write limits 0 to pi by 2, here also 0 to pi by 2, 8 by pi square into this whole. Now you could simplify, integrating cos t and then substituting limits and all, you know. Finally this whole value becomes 1, so answer will be 8 by pi square. Okay. Next question, integral 0 to 1 cot inverse of x square minus x plus 1. Integral 0 to 1, as it is, if you integrate it becomes very complicated. Even if you take integration by parts, by taking this as first function, second function as 1, so complicated. So what I will do is, first I will simplify this. If you want to simplify cot inverse, first express it as tan inverse. I will write it as tan inverse of 1 by x square minus x plus 1. Now I am going to write this as x minus y by 1 plus xy, then apply the formula tan inverse of x minus y by 1 plus xy is equal to tan inverse x plus tan inverse y, tan inverse x minus tan inverse y. Integral 0 to 1 tan inverse of, you can write the denominator as 1 plus x into x minus 1. Now numerator is x minus of x minus 1, it is 1 only. Now according to the formula tan inverse of x minus y by 1 plus xy is equal to tan inverse x minus tan inverse y, it becomes integral 0 to 1 tan inverse x minus tan inverse of x minus 1 dx. Now I will write separate integrals. Integral 0 to 1 tan inverse x dx, and we can take minus sign common, make this plus. It becomes plus integral tan inverse of 1 minus x limits 0 to 1. Now if you use the property replacing x by 1 minus x, this becomes tan inverse x. So it is equal to integral 0 to 1 tan inverse x dx plus, applying the property, this is also equal to integral 0 to 1 tan inverse x. So it is 2 integral 0 to 1 tan inverse x. Okay. Now integrate by parts. First function is tan inverse x, second function is 1. So it will be 2 into tan inverse x into 1 minus integral 0 to 1 derivative of the first function into integral of the second will be x by 1 plus x square. Here we have to substitute limits 0 to 1. Now it is 2 into, substituting 1, tan inverse 1 is pi by 4, substituting lower limit is 0, it is 0, minus integral of this is half log 1 plus x square, multiplying and dividing by 2, it becomes f dash x by fx, its integral is log mod fx. So it is half log 1 plus x square. Then we have to substitute limits 0 to 1. Then finally you are going to get pi minus log 2. Okay. Next question. If 2f of x plus f of minus x is equal to 1 by x into sine of x minus 1 by x, find integral 1 by e to e f of x dx. First we have to solve this functional equation and find the direct definition of f of x. How? You replace x by minus x. This is true for all values of x. So I can replace x by anything. If I replace x by minus x, this becomes 2f of minus x plus f of x is equal to, if you replace x by minus x, it remains same. It becomes, here minus sign will come, here also minus sign will come, minus and minus will multiply plus. You will get 1 by x into sine of x minus 1 by x. So now by direct subtraction, you will get f of x is equal to f of minus x. Is it not? Therefore, substituting f of minus x as f of x, first equation becomes 3f of x is equal to 1 by x into sine of x minus 1 by x. So f of x will be 1 by 3x into sine of x minus 1 by x. Now let us take that integral. Integral 1 by e to e, f of x is what? 1 by 3x into sine of x minus 1 by x dx. Now denote it by I. If you remember, in the earlier class we have discussed one point that when reciprocal numbers are present in the limits, we have to substitute x is equal to 1 by t. So here e and 1 by e are reciprocal numbers, no? So put x is equal to 1 by t. Then dx is equal to minus 1 by t square dt. Then what will be the new limits? If x is 1 by e, t is equal to e. If x is e, t is equal to 1 by e. Integral e to 1 by e, this becomes t by 3. 1 by x is t, no? Into sine of 1 by t minus t into dx is minus 1 by t square. I will write minus sign here, dt by t square. T cancels and remove this minus sign and interchange the limits. Then you will get integral 1 by e to e. After cancelling t, another t is there, not t into 3. You will get 1 by 3t into, we can write this as sine of 1 by t minus t can be written as t minus 1 by t, and then we have to put minus sign here, dt. If this is I, this is minus I, whether it is x or t, function is same, limits are same. So this is equal to minus I. If I is equal to minus I, then 2I is equal to 0 and I is equal to 0. So the given integral is g equal to 0. Next question. Show that integral 0 to x e power xt into e power minus t square dt is equal to e power x square by 4 integral 0 to x e power minus t square by 4. Here t is the variable with respect to which we are integrating and x is independent of t. Now if you in the rough work, if you look at the given integral, it is e power tx minus t square, that is t into x minus t, and it has to become what is this? This is integral 0 to x e power x square minus t square by 4. Okay. So to modify this integral into this form, this is x plus t by 2 into x minus t by 2, no? So I will put t is equal to x plus some other variable z by 2. Okay. Then automatically x minus t will be the other x minus t by 2. So we are going to get this. Here you understand that x is constant, means independent of t. New variable is going to be z. Okay. Now what will be the new limits for this substitution? Before new limits, let us differentiate. Dt is equal to x is independent of t, no? So derivative is 0 plus for z by 2 it is dz by 2 derivative. So this will be LHS. LHS is equal to integral e power x plus z by 2 into x minus t will be x minus of x plus z by 2 will be what? X minus z by 2 into x minus z by 2 into dx is not dx, it is dt. So dt is dz by 2. Now what are the new limits? If you take t is equal to 0, if you take t is equal to 0, what are you getting? Z is equal to minus x. If you take t is equal to x, you will get z is equal to plus x. This is now take half outside, minus x to plus x e power x square minus z square by 4 dz. Now, in terms of z, this is even function, replacing z by minus z, it remains same now. Limits are minus x to plus x. So, what can you do? You can write this as even function property, 2 integral 0 to x, the same function. I can write this function as e power x square by 4 into e power minus z square by 4 into dz, 2 cancels. Now, x is constant independent of z, so I can take e power x square by 4 common, e power x square by 4 integral 0 to x e power minus z square by 4 dz. Now, we can replace z by t and get the RHS. So, is equal to RHS. Okay. Next question, if f of x is equal to sin x by x and integral 0 to pi by 2 f of x into f of pi by 2 minus x is equal to k integral 0 to pi f of x dx, find k. Here first let us take the LHS. Integral 0 to pi by 2 f of x means sin x by x into f of pi by 2 minus x means sin pi by 2 minus x cos x by pi by 2 minus x. Now, we have to simplify this and get it in the form of some constant integral 0 to pi f of x dx. So, for that first multiply and divide by 2 so that you can write numerator as sin 2x. By this becomes x into pi minus x. Okay. Now, if you take separately integral 0 to pi sin 2x by x into pi minus x. No, before that let us write this 1 by x into pi minus x as partial fractions. We will write it as integral 0 to pi by 2 sin 2x into, we can write 1 by x into pi minus x as 1 by x plus 1 by pi minus x. Then if you simplify, you are getting numerator as pi, so you have to divide by pi dx. Okay. Now, take out that pi, 1 by pi into, I will write separate integrals, integral 0 to pi by 2 sin 2x by x dx plus again 1 by pi into integral 0 to pi by 2 sin 2x by pi minus x. Okay, now we want to get the limits 0 to pi, and also it should become f of x, means this 2x should become x. How is it possible? Let us solve it on the next page. 1 by pi integral 0 to pi by 2 sin 2x by x dx plus 1 by pi into integral 0 to pi by 2 sin 2x by pi minus x. Okay. Now put 2x is equal to t. Then 2 dx is equal to dt. Then this will be 1 by pi into, what will be the new limits? If x is 0, t is 0, if x is pi by 2, t is pi. So you will get the limits 0 to pi. This becomes sin t by x is t by 2 and into dx is dt by 2. So 2 cancels, dt, and next plus 1 by pi into integral, limits will be 0 to pi, numerator becomes sin t and denominator is x is t by 2, now pi minus t by 2 into dt by 2. If you take 2 LCM, first one is 1 by pi integral 0 to pi sin t by t dt. Now second is 1 by pi integral 0 to pi sin t by 2 pi minus t. Now this is f of t, or you can write f of x. Now the problem is the other. Now how to convert this into f of x form? If you replace t by pi minus t, you are getting sin t by pi plus t. Again replacing t by pi minus t, you are getting the same integral. So we can write this as, 1 minute, let us check the calculation in the previous page. Oh, here pi minus 2x is coming, that is the mistake we made. Pi minus 2x means here the entire calculation will change. What we will get, again multiply by 2 and divide by 2. Okay. Now you can write this as 1 by 2x plus pi minus 2x. So into 2 will be extra. Okay. Then divided by pi will be same. So we will get 2 by pi, here 2 by pi 2x. Now putting 2x is equal to t, this is 2x, pi minus 2x, 2 by pi, 2 by pi, and this is 2t, sorry. So what we get here, sin t by t dt, this dt by 2. Next 2 by pi into, here directly this becomes t. Okay. Now what is the extra? This 2 cancels here and there, so 1 by pi will be same. Here you are going to get pi minus t only. Now replacing t by pi minus t, what happens? Numerator is sin t, denominator becomes t, is it not? So this becomes t. So this and this are equal, so adding them we can write 2 by pi integral 0 to pi sin t dt, means we can write sin x by x also, which is equal to 2 by pi integral 0 to pi f of x dx. Now see the question, it is k integral 0 to pi f of x dx, so therefore k is equal to 2 by pi. Okay. Next question, if integral a to b mod sin x dx is equal to 8, integral 0 to a plus b mod cos x dx is equal to 9, find a and b. All of you know the graph of sin x. Graph of sin x will be like this: 0, pi, 2 pi, 3 pi and so on. It continues in the same way. If you take mod, what happens? This part will get reflected about the x axis, this part will get reflected about the x axis. So the graph of mod sin x will be like this. In this way it continues. Now clearly it is periodic function with period how much? Pi. So this area completely curve is above the x axis, and this area is exactly equal to integral 0 to pi f of x dx. And what is this area? Let us calculate. Integral 0 to pi sin x dx. Integral of sin x is minus cos x. Substituting limits 0 and pi, you are going to get 2. So area under one loop is 2, and this is a integral multiple of 2, 4 into 2. That means 4 loops like this will give you 8 up to how much? 4 pi. 2 only, no? 0 to pi, cos pi minus 1, it is 2. Okay. So since we start, a to b, no? Okay. Integral 0 to 4 pi mod sin x dx is exactly 8. Now suppose you have integrated from some point to the same length extra. Suppose this is k, integral k to 4 pi plus k, then also you will get the same area because this part will be added here. What does it mean? From wherever you start, you integrate up to 4 pi units, up to an interval of 4 pi, the area will be 8. Therefore what we can say is difference between the upper limit and lower limit must be equal to 4 pi. Therefore we get b minus a is equal to 4 pi. Okay. Now coming to second integral, graph of cos x will be like this. in this way. The same graph should be shifted by pi by 2 units towards left. If you take mod cos x, the graph will be like this. If you take mod cos x, it will continue in this way. Then see, this and this are almost identical, just position is different. So if this area is 2 square units, this area is 2, this area is 2, and this total area is 2, means this area is 1. Now you started from 0 and you are integrating up to a plus b. So what should be a plus b? You can easily guess. 1 plus 2 plus 2 plus another 2, how much? 7 only, so another 2. Okay. And what are these limits? This is pi by 2, this is 3 pi by 2, this is 5 pi by 2, this is 7 pi by 2, next will be 9 pi by 2. Correct? Next will be 9 pi by 2. So a plus b must be 9 pi by 2, or we can write b plus a. Then by adding and subtracting you can calculate the values of a and b. Okay, you finish it. Next question, integral 0 to 2n pi integral part of sin x plus cos x. Sin x plus cos x is a periodic function with period 2 pi. So using the periodic property, I will write the given integral as n integral 0 to 2 pi integral part of sin x plus cos x. Now to calculate this, we have to draw the graph of sin x plus cos x, and you know that sin x plus cos x is multiplying dividing by root 2, it will be root 2 into sin of x plus pi by 4. Okay. So I am going to draw the graph of y is equal to sin x plus cos x. What is the range of sin x plus cos x? Minus root 2 to plus root 2. Okay. And we are going to integrate from 0 to 2 pi. So I am taking on x axis, I am taking 0, pi by 2, I am going to take 0, pi by 2 here, pi here, 3 pi by 2 and 2 pi. So I am going to draw the graph in this interval. Now it is sine function only. What is the graph of sin x? Graph of sin x will be this, y is equal to sin x. Its maximum value is 1, minimum value is minus 1. If you multiply by root 2, these points of intersection with x axis remain same, but only the maximum values, minimum values will change. So graph of root 2 sin x will become like this. Maximum value becomes root 2 times, minimum value also becomes root 2 times down. Okay. Next, in place of x, if you write x plus pi by 4, then you should shift this graph by pi by 4 units towards left. So this is pi by 2 now, so pi by 4 will be somewhere here, minus pi by 4. Now we have to draw the same graph starting from here. And this maximum value occurs at pi by 2 now here, shifting it by pi by 4 towards left. Now the maximum value occurs at pi by 4. This pi by 2 point becomes pi by 2 point. Maximum value occurs at pi by 4, and again this point of intersection is pi. If you shift it by pi by 4 units, pi minus pi by 4, 3 pi by 4, it intersects here. Again this minimum point is what? 3 pi by 2. Now 3 pi by 2 minus pi by 4 will be here. 3 pi by 2 minus pi by 4 will be 5 pi by 4. So minimum value occurs there. Next, intersection point with 0 pi, this is 2 pi. Okay, this 2 pi will be shifted by pi by 4 units. 2 pi minus pi by 4 will be 7 pi by 4. So after getting the minimum, it will increase like this. So this is the complete graph of sin x plus cos x. What is the maximum value? Root 2. Minimum value is minus root 2, and at 2 pi it is 1. Cos 0 at 2 pi it is 1, so it will become like this. This is 1. Now to find out its integral part, what we do is draw the lines at integral values of y. This is minus root 2, next comes minus 1. At minus 1, draw a horizontal line. Again at 0, this line. Again at 1, okay. Now we want to integrate from 0. What is this point of intersection? Sin x will be sin x plus cos x will be equal to, this will be equal to 1 for what value of x? For x is equal to, I think after 0 it is pi by 2. Okay, for x is equal to pi by 2, this point is pi by 2. Next, this point is 3 pi by 4, and this point will be pi only, and this point will be, this one will be pi or what? If it is equal to minus 1, sin x plus pi by 4 will be equal to minus 1 by root 2, then x will be, yes, pi. Next is 3 pi by 2, correct. This is 3 pi by 2, 7 pi by 4 and 2 pi. Now I will calculate the integral parts in different intervals. First consider 0 to what pi by 2. In the interval 0 to pi by 2, sin x plus cos x lies in the interval 1 to root 2. What is the integral part? 1. So first I will write n is there outside, n into, I want to integrate from 0 to 2 pi, but in different intervals of x there are different values of sin x plus cos x. In the interval 0 to pi by 2, integral part of sin x plus cos x is 1. Which interval? 0 to pi by 2, its integral part will be 1. Next, from pi by 2 to 3 pi by 4, it lies between 0 and 1, integral part is 0. So pi by 2 to 3 pi by 4, integral part is 0. Next, 3 pi by 4 to pi, if x lies between 3 pi by 4 and pi, sin x plus cos x lies between minus 1 and 0, then integral part will be minus 1. So next is pi by 2 to 3 pi by 4 to. Three pi by 4 to pi. Its integral part is minus 1. So minus 1 into dx. I will write the remaining integrals here. Pi to 3 pi by 2, it lies between minus root 2 and minus 1, integral part is minus 2, plus pi to 3 pi by 2, it is minus 2 dx. From 3 pi by 2 to 2 pi, 3 pi by 2 to 7 pi by 4, again it lies between minus 1 and 0, integral part is minus 1. 3 pi by 2 to 7 pi by 4, minus 1. Next is 7 pi by 4 to 2 pi, integral part will be 0 because it lies between 0 and 1. So plus 7 pi by 4 to 2 pi, it is 0 dx. Now you know how to calculate these values and finish. I think it will be something like minus n pi. You will get minus n pi. Minus n pi or plus n pi, I do not remember. So only calculation part is left, you finish it. Okay. Next, if f of x is equal to x plus integral 0 to 1 x y square plus x square y into f of y dy, find f of x. In the integral, definite integral, when there are two variables, okay, so you can assume that one is independent of the other unless separately given some relation between x and y. So what we can do is, we can take out, we are integrating with respect to y, so we can take out x, treating x as constant. So if you write f of x as x plus, you separate into two integrals, from each integral take out terms of x. From the first integral you can take out x, x integral 0 to 1 y square f of y dy. Plus from the second integral you can take out x square, integral 0 to 1 y into f of y dy. Okay. Now we know that whatever is the function f, integral 0 to 1 something in terms of y with respect to y will be a constant. This is totally a constant. Similarly, this is totally a constant. If the limits of the different integrals are constants, then the definite integral is a constant. So this is some constant, this is some constant. Now you can easily observe what kind of function is f. X into 1 plus x into some constant plus x square into some constant. So it is a quadratic function without constant term, is it not? So f of x is a function of the form ax square plus bx. After observing it, we assume that f of x is ax square plus bx. Then what is a? This one. A is equal to integral 0 to 1 y into f of y. Already we assumed f of y like this, no? So f of y will be ay square plus by dy. Okay, a is equal to coefficient of x square. Now if you simplify this relation, this is a into y cube. What is the integral? A into y power 4 by 4 plus b into y square is there, its integral is y cube by 3. Now limits 0 to 1. If you substitute limits 1 and 0, you will get a by 4 plus b by 3. It is equal to a. Taking a by 4 this side, you will get 3a by 4 is equal to b by 3. So we get 9a is equal to 4b. We got one relation between a and b. Now compare the coefficient of x. B is equal to, b is coefficient of x in the function f of x. What is the coefficient of x here? 1 plus this integral, 1 plus integral 0 to 1 y square into f of y. Again f of y is ay square plus by, ay square plus by dy. Now it is 1 plus a into, it is y square into y square, y power 4, integral of y power 4 is y power 5 by 5 plus by cube, its integral is by power 4 by 4. 1 minute. Okay, limits 0 to 1. So b is equal to 1 plus a by 5 plus b by 4 multiply by 20, you will get 20b is equal to 20 plus 4a plus 5b. Therefore 4a plus the 4a minus 15b plus 20 is equal to 0. You got one equation here, another equation here. Can't you solve these two equations and find a and b? After finding a and b, write the function f of x. Okay. You finish the calculation. We will move on to the next question. This is bit long. We have only 2 minutes left. So if there is a simple question, we will solve. Integral 0 to 1 x power alpha minus x by log x. In this question, we are going to apply a different method, which is definitely not dependent on integration. You can observe that this indefinite integral is not in the standard form. No standard substitution, no integration by parts, nothing will work. So what we do is, we take the definite integral as I of alpha. Why I of alpha? This is in terms of x. After integrating, you will substitute x is equal to 1 and 0. Finally, the definite integral will be in terms of alpha. So, the total value of the definite integral will be in terms of alpha. So, I am assuming it as I of alpha. Then differentiating it both sides with respect to alpha, I dash alpha is equal to integral 0 to 1. When you are differentiating, this integral is with respect to x, but we are differentiating with respect to alpha. So, we will keep the integral as it is and we will differentiate the function with respect to alpha. What is the derivative of x power alpha with respect to alpha? It will be x power alpha into log x minus 0, and log x is just like constant, x is just like constant, we are differentiating with respect to alpha, dx, log x cancels, then integral 0 to 1 x power alpha will be x power alpha plus 1 by alpha plus 1 between limits 0 and 1. Substituting the limits, you will get 1 by alpha plus 1. If I dash alpha is 1 by alpha plus 1, what is I of alpha? I of alpha will be its integral. Integral of I dash alpha is I of alpha. What is integral of 1 by alpha plus 1? Log alpha plus log mod alpha plus 1. But this is indefinite integration now. So, we have to write constant of integration plus c. How to find c now? Substitute some suitable value of alpha. I will substitute alpha is equal to 0. Then this will be log 1 0 plus c. What is I of 0 in the given function? This is I of alpha. Substitute alpha is equal to 0. What you will get? This will become 1 minus 1 0, indefinite integral, definite integral 0 to 1, 0 dx is 0. So, I of 0 is also 0. So, c is 0, then I of alpha is finally log mod alpha plus 1. That is all. Okay. So, with this I am going to conclude, and we are going to start, we are going to continue the problems in the next class.